Okay, you guys, so today we're talking about transformations of graphs. So we are actually gonna do like a project with this next week, which will be kind of fun. But because there is a ton to transformations, we'll do notes today. I'll finish them up on Monday and then I'll give you that project to get started with. So we will not get through everything today, but no worries. So first thing, let's go ahead in our calculator. We're gonna go ahead and type in some different equations. So that first one is the absolute value of x. So if you remember where that button is, if you go to your y equals, because we're typing in a graph, and then if you go to math, which is under second and alpha, go to math, and then over to number, and this is where that ABS is, that absolute value. So go ahead and type that in, and then use the X key up here right next to alpha. And then to see it, you can go ahead and graph.
Yeah.
Okay, so y equals, everyone good? Y equals. Now to get the absolute value signs, you go math. And then you go over to number, so use your arrow key to go over to NUM. And then number one is ABS, the absolute value, so you can go ahead and hit either one or hit enter. And then it's gonna give you absolute value signs back in your y equals. And then you can go ahead and hit the X. And then graph it. And we should be looking at a V. If anyone's not looking at a V, let me know. Yeah, you have something else in there, so. There you go. You just have another equation in there. Okay. Cool, everyone good? Questions, concerns? No. Okay, so looking at this graph right here, we're just gonna draw them as we go. So our absolute value of x, where's my x-intercept? 0. Isn't that my y-intercept too? And then it's just gonna be, it's like a V like this, okay? So that's the first one. Now let's go ahead, go back to your y equals. Don't clear out what you have in there. We're gonna add these equations, okay? So now use your arrow key to go down to y2, and we're gonna type a second equation in. So this time we need the absolute value of x minus 5. So that was absolute value signs, remember they're math, over to number, and then hit enter, and then go ahead and type x minus 5, and all of it should be inside of the absolute value signs. And then you can go ahead and graph it. And we should look at that one and see something different. What does this one look like? Caden, what do you think?
Same thing, just moved over.
Yeah, same thing, just moved over. How many is it moved over?
5.
Yeah, it's gonna be moved over which direction?
Right.
Yeah, I'm going right 5. Okay, so I have the same thing, I'm just moved over 5. Okay, let's go ahead, go back to your y equals. Go down to y3, and this time we want to type in the absolute value of x plus 5. So same thing, find your absolute value signs. And then type in x plus 5, all of that in the absolute value. And then graph it. And then, Haley Winter, what are we looking at? Yeah, it's just gonna go to the left now. So we got a V again. We're just going to the left. Okay. All right, let's go down. Let's do number 4. So y equals, go down to y4, and then math, absolute value, and then this time we just have the x in the absolute value, and then we need the minus 5 on the outside of our absolute value sign. Haley Marie, what do you think for this one?
It's just down 4.
Down 4?
I think.
I think it's down 5.
It's 5.
Yeah,
Okay.
but it's close. You're good. So still a V, but this time I just come down 5. Okay, and then let's go ahead, type in the last one. Ocean, what's going on with this last one?
It's just up 5.
Yeah, it's gonna be up 5, so. So I have a V again, but it's just up 5. So you can see that we have the exact same graph 5 different times. It's just shifted around. So everything we're dealing with today is gonna be transformations. And we'll explain all that in a couple slides, so. Okay, so shifting a graph up or down. So to write an equation of a translated graph, so one that's transformed, that it's moved around, you start by writing the parent function, which is just like your original equation. So a parent function would just be how we started with y equals the absolute value of x. That would be your parent function. So it doesn't have any numbers with it. It's just the x. Or like y equals x squared. That would be a parent function. So then it says if the new function is shifted down, then you're going to use minus whatever number you're going to be shifted down. So if you're going down, you use minus, which makes sense because you're going to the negatives, like you're moving it down into the negatives. So you're subtracting your graph, you're moving it down. If you're going up, you're going to write plus whatever number, however many you're going to move it up. So then it does say so our problem, it says write the equation of the orange graph, and then we're gonna figure out what the domain and range of it is. So first of all, before we talk about the orange one, the blue graph right there, do you know what the parent function, what an equation for that blue graph is? Anyone have any ideas? What about y equals x squared? Does that sound familiar? Yeah. So yep, so the blue graph is just a quadratic, it's just y equals x squared, okay? So our parent function that we're starting with, so the blue graph is y equals x squared. So the first step is always to figure out like what shape you're dealing with, what your parent graph is. So the ones that we'll use is, this is a quadratic, it looks like that U right there. And then y equals the absolute value of x, that's the V graph, okay? Or we could have just a straight line, like the y equals x, okay? So this graph would be a graph like this one will be like this, and this one will be like this, okay? So those are the parent functions that we're gonna use to write our transformations. So we could be using any of these 3, okay? So because that graph looks like a U, I know I wanna use my y equals x squared equation. And then if I look, so now I'm trying to write this equation for my orange graph. How many am I shifted? Or where is that graph going? Jade, what do you think? Yeah, how many? Yeah, down 3. So if I need to start, I need to write my parent equation, which is y equals x squared. And then if I'm going down 3, do I want to go ahead and say plus 3 or minus 3? Jade, what do you think? Yeah, minus 3. So my equation of that orange graph is y equals x squared minus 3. And then it says, what is the domain and the range of this orange graph? So my domain, let's see, Cooper, what do you think my domain is gonna be?
Which one?
For the orange one. 4. Okay, so where do I start? What's my farthest left point?
Maybe 2.
Okay, and where do I end?
2.
Okay, do I want brackets or parentheses?
Brackets?
I do want brackets, yep, because they're filled in points. So I would go from -2 to +2, just like that. Okay, so that's my domain. So your farthest left point to your farthest right point. So -2 to 2. Okay, and then Mia, what do you think my range is gonna be for this orange graph? negative 2 to negative 3. So are you looking, so range, we're looking at our y values. So you went from negative 2, like down here, or negative 2 over here on your x,
On the X.
on the x. So if we go from our y's, what's my lowest y value? Okay, and then what's my highest y value?
1.
Yeah, so I'm going from negative 3 up to positive 1. And do you think I want brackets or parentheses? Yeah, yep, because they're filled in points. So I would want to go from negative 3, so the bottom, up to positive 1. Okay? So that's for the orange graph. The blue graph, does it have the same domain as the orange graph? What do you guys think? Yeah, because don't they both go from negative 2 to 2? They're both the same left to right. But are they the same range? No, because the one was shifted down. So this one would have a range of 0 up to 4 versus we said it had a range of negative 3 to 1. Okay? So when you're shifting it up or down, your range is going to change. But when you're, like, your domain is not going to change. The domain would be the same. Okay? All right, left or right? So to write your equation for when you're shifting left or right, what we need to do is we start by writing our parent function again. And then this is the one that's a little bit tricky. So it says if the function is shifted to the left, then we actually use the plus sign. So even though it goes to the left, you'd think like minus because it's going to the negative. It actually uses the plus sign. And the reason for that is because if you have an equation, and we'll get into this in the quadratics chapter, but so like say I have, we'll get into it, okay? So basically, so if you're going to the left, you use a plus sign. And you have to put it in your parentheses, and then the squared goes on the outside, okay? So you start with your parent function, you give yourself some parentheses, and then you're gonna write the number that you're going to the left is plus that number, and if you're going to the right, it's minus that number. So then, looking at this blue graph right here, this is our parent function again. So that's just y equals x squared. So then looking at the green graph, Keaton, how many do I go over? 3. And I'm going to the right, right? So if I'm going to the right, Kaden, do I want to use plus or do I want to use minus?
The x minus 3.
Yeah, it's going to be x minus 3. So I would write it like y equals parenthesis x minus 3 squared. Okay, so I put with the left or right, I put it in parentheses. Or if it was the absolute value, I would put it in my absolute value. So the left or right always goes in parentheses or in absolute values, okay? And then you would keep your squared on the outside. Okay, so then the reason that it's minus, if I were to solve this, if we think about solving for x-intercepts like we were talking about on that IXL, when you solve for your x-intercept, can we put 0 in for y? Because if we look at right here, this x-intercept right here, its coordinate is at 3, 0, isn't it? It's not up or down or anything. So the y value, since it's not moved up or down, is 0. So if I take 0 is equal to x minus 3 squared. So if I were to solve this out, x minus 3 squared, doesn't that mean I have 2 quantities of x minus 3? So I would have like x minus 3 times x minus 3. Is everyone okay with that? Okay, so then let's go ahead, let's FOIL this out. Let's multiply it out. So Faith, go ahead and help me. So x times x would be 1x squared, right? You're good. So negative 3 times x would give me? Yep. And then x times negative 3 would give me? Okay. And then negative 3 times negative 3 would give me? Yep. And then can I combine my negative 3x and my negative 3x? What would I have? Yeah, negative 6x. So then if I have x squared minus 6x plus 9, if I were to solve all of this out, this is hard because you guys don't know all this yet. So if we solve all of this out, basically we end up getting, I'm sorry I just did that. We're gonna do it a different way. So the x minus 3 squared is equal to 0. I could set each of these factors equal to 0. So I have x minus 3 is equal to 0 and x minus 3 is equal to 0. I can set each of those factors equal to 0. So then if I take this and I'm trying to solve it for x, I can add my 3. So x would equal 3. So your x-intercept is 3. Do you guys see that? So that's why it's minus, because when you solve it out, your x is equal to 3. Okay? So when you're going to the right, you use minus. When you're going to the left, you use plus. So it's opposite of what you think, basically. Okay? And we'll get into all that stuff in just a couple sections. So we'll do a whole chapter on quadratics, which will make more sense. But for now, basically, if you can just remember, left is plus, right is minus. Okay. So then, reflecting. So reflecting functions over the x-axis. So it says graph f of x is equal to 2x minus 6 by plotting the x and y intercept. So if we think this is just y equals mx plus b, right? This is just a linear function. So where would my y-intercept be for something like that? Cooper, what do you think?
-6.
Yeah, negative 6. Okay, and then Cooper, what's my slope?
2.
2, okay. Okay, so I'm down here at negative 6, and then my slope is 2. So when my slope is 2, does that mean I go up 2 over 1? Yeah, okay. So if I go up 2 over 1, up 2 over 1, up 2 over 1, I end up finding out that my x-intercept is at 3. Okay? And then I can go ahead and draw my line. My lines are not perfect, it's okay. Okay? Okay, everyone okay with how I graph that? Okay, so now, if I'm gonna reflect, it says, now let's reflect these points over the x-axis. So this one's my x-axis, right? If I take this point right here, the negative 6, 0, or 0, negative 6, if I reflect it, it's gonna be up here at 0, positive 6. Does everyone see that? So I would just take it, flip it over, and it's gonna come up here. So I'd be up at 1, 2, 3, 4, 5, 6. So now I have a point up there. Now this point right here that's at 1, negative 4, what would its coordinates be when I reflect it? Mackenzie, what do you think? So if I'm gonna reflect it up, so positive 4, so out here on the x. Yep, you're good so far. So positive 1. And then the opposite of negative 4 would be? Yeah, so that's gonna be up here at 1, positive 4. Okay, so then this point right here that I'm at 2, negative 2, Haley Winter, where's that one gonna be?
Positive 2, positive 2.
Yeah, positive 2, positive 2. What about this point right here that's at 3, 0? When I reflect that, is that gonna change? No. So here's my new line. So if I take this graph right here, I reflect it over my x-axis, it's gonna give me this line right here. Is everyone okay with that? Yep. So now it says I need to figure out what the new equation of this line is. So looking at this, thinking about what we know about linear graphs, we know it's gonna be in y equals mx plus b, right? So I'm trying to write a linear line. What's my y-intercept of this graph? 6, yep. So I can go ahead and fill that in for my b. And what's my slope of this gonna be? What, Haley? Yeah, it is. Yep, it's -2. So, because I'm going, instead of going up 2 over 1, I'm going down 2 over 1. So it's a -2 slope. I'm going down, I'm decreasing. So my new equation would be -2x plus 6. Okay? So being able to reflect something and then writing a new equation for that graph. Okay, so here's just a picture you can see. So it says, so this time we have some absolute values. So it says, when writing an equation of a function that's been reflected over the x-axis, put a negative sign in front of the whole equation. So our original equation we had for this line, we had y equals 2x minus 6. So that was this equation right here. If I were to put a negative in front of the whole thing, so if I have y equals -2x minus 6, if I distribute this negative, Paige, what would I have? Yeah, -2x and then +6. Is that what I had over there? Yeah, so when we're writing equations, when we're reflecting over the x-axis, all you have to do is take your original equation, put a negative out front, and then distribute it, okay? And then that's gonna give you your reflected equation, okay? So just negative out front for when you're reflecting over the x-axis. So let's try it with this absolute value graph. So it says, the red graph, so this one up here, is the graph of absolute value of x minus 3. And you can see that the minus is inside of the absolute value. So it's like it's inside the parentheses. And because it's minus, I'm gonna move to the right. Okay, so you can see this graph has been shifted 3 to the right. Okay, so now I need to reflect it over the x-axis, and I would need to write this equation for what my new green graph would be. So what do you guys think? So the easiest way to write an equation, yeah, Kaden?
Wouldn't it just be half times x equals negative of the absolute value of x minus 3?
Yeah, exactly. Negative of the absolute value of x minus 3. That's all it is. If you were to type that into your calculator, it's going to give you that green graph right there. So you just throw a negative out front anytime you reflect over the x-axis. Okay? How are we feeling, guys? I know this book kind of jumps into it like right away and it's kind of tough, but questions from anyone?
No.
Okay. So let's go ahead, let's reflect over the y-axis now. So we're using the same example. So I have the graph of 2x minus 6. That was this one right here. I don't need this one anymore. Okay, so here's our graph of 2x minus 6. We already graphed this one. So now it says, let's go ahead and take our points and let's reflect them over our y-axis. So if I take this point right here, the 0, -6, that's on my y-axis, when I reflect over the y-axis, is it gonna move? No. Okay, what about this point that's at 1, -4? If I'm reflecting, taking this graph, I'm going this way. Ocean, where's that point gonna be?
For which one?
For 1, -4.
It's just gonna be on the opposite side, just right on the other side of it, so, -1.
Yeah, -1, -4, it's just gonna go right over there. Okay? Jade, what about this one that's at 2, -2? Where's that one going?
-2 and -2.
Yeah, -2 and -2, so I'm gonna come over here and put it right here. And then Nina, what about the last one? So this one that's at 3, 0, where's that one gonna be? Yeah, negative 3, 0. So here's that one, and then I can go ahead, that was a very poor line, guys, I'm sorry. So there's that line right there, okay? So here we had our original equation. I take it, I reflect it over the y-axis, and now I have this line right here. So let's write an equation for this graph. So we know it's a straight line, so it's gonna be y equals mx plus b. Where is my y-intercept, Cooper? Okay, and then what's my slope of that one? Positive 2?
-2.
Yeah, negative 2, so it'd be y equals negative 2x minus 6. So you can see it's decreasing, so it's gonna be going down, so it's the negative 2 slope, and that would be my equation right there. Okay. Okay, so then it says when we reflect over the y-axis, what we want to do is, all we do is we put a negative sign in front of the x part, and then we leave everything else the same. Because if we think our original equation was y equals positive 2x minus 6, well, if I put a negative just in front of the x part, that gives me negative 2x minus 6. And isn't that our equation we came up with? Yeah. So when you reflect over the y-axis, you only put a negative in the x part. You leave the rest the same, okay? So for x-axis, it's negative for everything. For y-axis, just for the x part. So then, I have the example. So if we have the equation negative 2x plus 4, and I need to write an equation for that graph that's going to be reflected over my y-axis. Let's see. Hillyberry, how would I do that?
Wouldn't it cancel out to be positive?
Yeah, because I would have negative 2x, which is going to cancel and be positive. So I'd have 2x, and then what's going to be with my 4?
Or no, it stays the same.
It's going to stay the same. So it'd be 2x plus 4. So here would be my equation of that line that's now reflected across my y-axis. Okay? Okay, so let's go ahead, let's just do a couple more. So it says writing equations of reflecting graphs. So I have f of x is equal to x squared minus 2, and we're reflecting it across the x-axis. So if I'm reflecting it across the x-axis, Haley Winter, what do you think I should do to write my new equation?
Negative in front of x squared.
Okay, a negative in front of x squared. What about what's going to happen with my negative 2?
Positive.
Exactly, yep. So I put a negative in front of the whole equation. So if I did negative x, squared minus 2, and I distribute it, it's exactly what Haley just told me. So I'd have negative x squared plus 2. So anytime you go over the x-axis, it's a negative in front of everything, so it changes the whole equation. Okay, so now let's use the same equation, but this time I'm going over the y-axis. Kaden, what would I have for this one?
Negative x squared minus 2.
Yeah, negative x squared minus 2. Because when I go over the y-axis, all I do is I change my x to a negative, but I leave everything else the same. Okay? And then it does say, let's go ahead, let's type them in our graphing calculator, just to check, make sure we did them right. Practice in our graphing calculator. So go ahead, you can clear out all those other absolute value equations, all 5 of those that we have in there. And then you can go ahead and in your y1 type in x squared minus 2, so our original. And then in your y2, go ahead and type in the one that's reflected across the x-axis, So this negative x squared plus 2, type that in your y2. And then make sure you use the negative sign, like down at the bottom next to enter, not the minus sign, or it's gonna give you an error. And then everybody should be seeing, the first one should be a U that opens up, and then the second one should be a U that's gonna open down. Because it was reflected across our x-axis.
So I think you're supposed to just go here.
Yeah, you're welcome. Cool, thank you.
Oh, so we don't have negative in front of the original, so we just want the original, the x squared minus 2. And then the other one, we want negative x squared plus 2. So still negative.
So negative.
Yep, so we're typing in the one that's reflected across the x-axis, so negative x squared. And then plus 2.
So you must have used the subtraction instead of minus. There you go. Okay, everyone seeing two graphs? One facing up, one facing down?
Oh, so we just needed the original one, just the x squared minus 2, so you can just.
Okay, so basically guys, so we'll pick these up on Monday, but you can see like, we can see how things are reflected, we know how to write the equations, we know how to shift stuff. So, go ahead, put your calculators back and then I'll just see you guys on Monday, okay?